All right, hello. This is day 2 of limits in our calculus unit here. And so there's Mr. Butterfly to remind you what you learned last time. Okay, so this is on limits, day 2. And I just want you to remember the basic definition of a limit before from the last video. Remember, your limit is another word for your intended height of your function. Okay, all right, so we're just going to do a quick example before we use that graph over there. So let's do this little example here. Let's say I had to do the limit as x goes to 3 with a plus sign, that means from the right, of this function, 2x squared minus 10. So look at that function. It has nothing weird going on when x equals 3. It's just a parabola, it's continuous, it's polynomial. So nothing's really special is happening at 3. There's no holes, no asymptotes, nothing weird. So it doesn't really matter that they're asking me from at 3 from the right. They could ask from the left also, or they could just ask a regular 3. All I have to do is plug in 3. So 2, 3 squared minus 10. So just because it has that little plus sign there doesn't mean that you can't just plug in 3. And so I get 9 times 2, so I get 18 minus 10 is 8. Okay? So just remember that. It doesn't have to be special. And also, you can always think of the graph. 2x squared minus 10 would kind of look like this. So, of course, as you go to 3, would be like maybe about there. All right. So for this next example over here, I'm going to draw a picture. So I'm going to have this function. My second example is going to be based off of this function, this piecewise function. All right, and the piecewise function goes like this. It is 3x minus 1, so y equals 3x minus 1 for all numbers, all x's less than 2. And it is the function 2x squared minus 3 for all numbers greater than or equal to 2. All right. So basically, we need to graph this or, see what's going on. Now, I could ask you right now, like if one of my questions is this, what is f of 2? So if I asked you for f of 2, then you would have to use this problem right here because that's where 2 is defined for. So if I asked you that right now, you'd plug in 2 there. So 2 times 2 squared, so that'd be 8, and 8 minus 3 is 5. So that's easy to answer there. So what I'm about to ask you, though, is the limit at 2. And so we have to think about that. So I know that this problem right here, you're not supposed to plug in 2. But if you kind of test to see, does this one start off where the other one leaves off? So if we plug in 2, we get 5 for this problem. What if you plug in 2 right here? Well, 3 times 2 is 6. 6 minus 1 is 5. So it also has a y value of 5. So basically, they end up in the same place. So why don't we graph them and you'll see that. All right, so 3x minus 1. So starts at negative 1, goes up 1, 2, 3 over 1, up 1, 2, 3 over 1. So I'm supposed to use that for everything to the left of 2. So actually this little spot right at 2, 5 is actually an open circle. And so to the left of 2, it goes back down like that. All right, now everything to the right of 2 and 2 itself, I'm supposed to use the second function, 2x squared minus 3. Well, 2x squared minus 3, if you think about it, it kind of looks like this picture a little bit. It touches down here at negative 3, and it has 2x squared, so it's kind of a skinny parabola. So by the time it gets up over here to the point 2,5, all it's doing is kind of going like straight up, or not straight up, but similar to. So, it's kind of like the parabola over here. So if it basically comes around and it goes, to negative 3 and it comes up there and then it keeps going up. But I don't need that part, I need the part after the hole. So I basically need the part that comes up like there. Okay? All right, so you can see here that the red one kind of fills in this hole because it picks up where the other one leaves off. So if I start asking you some questions like, what is the limit of this function as x goes to 2, you could say to me, oh, well, it's 5 because both sides go to 5. And so there is no discontinuity because basically the one starts where the other one leaves off. Okay? All right, so let's try another piecewise function. And let's do this one. F of x equals negative x plus 5. So y equals negative x plus 5 if x is less than or equal to 1. And it's y equals 2x plus 4 if x is greater than 1. All right, so those are just two linear functions. So I want to ask you this. What's the function's value at 1 itself. So if it's 1 itself, you see that I'm going to be using this guy up here. So if I plug 1 into that, I get negative 1 plus 5, so I get 4. So I'm going to ask you a couple questions. What's the limit as x goes to 1 from the left? The limit, oh my God, I wrote that so horribly. Oh my goodness. Oh, erase that. I don't know what I was thinking. All right, the limit as x goes to 1 from the left of my function. The limit as x goes to 1 from the right of my function. And then the overall limit as x just goes to 1 in general of my function. Okay, so let's draw the picture at this point and then see if that can help us a little bit too. Now 1 from the left, so I can tell that's to the to the left of 1. So basically you can kind of tell I'm going to be using this problem right here. And then 1 from the right, it's going to be using this problem right here. And then we have to see if 1 overall makes sense. All right, so 1 from the left. So let's draw that. Negative x plus 5. So I'm going to start at 5 and go down 1 over 1, down 1 over 1. So I would keep going there, but I'm only supposed to do this line. This line only exists for everything less than or equal to 1. So I'm going to erase everything after 1. So everything after 1 would be everything right there. All right, so that is right there. And 2x plus 4. So 2x plus 4 starts at 4 and goes up 2 over 1. Up 2 over 1. So that line right there cuts through the other one, but it's only supposed to exist for everything after 1. So this guy is not supposed to be there, and everything after 1 means I have an open circle there, and it's everything to the right. Okay, so I'm going to do that a little bit better. Okay. All right, so answer to my questions from earlier. Everything 1 from the left, I'm using this blue graph over here. And so 1 from the left, it's approaching a height of 4. 1 from the right, I'm using the red one. So from the right, it's going to a height of 6. And you see that mismatch right there? That is bad for 1 overall. This does not exist. Okay, the left and right exists, but the overall has to match, and it doesn't. All right, so that's using pictures. Most of the rest of these we're not going to do pictures, but let's try another method here. So let's have a limit, and x goes to 2. Now I showed you a little bit of factoring last time. So let's look at this problem, x to the 4th minus 16. So if I try to plug in 2 right now, I get 8 minus 8 on top, and I get 16 minus 16 on the bottom. I get 0 over 0. That's indeterminate. You can't you can't figure that out. That has no answer right there. Something has to be fixed about it. So you can always try to factor. All right. So let's see, because graphing this would be kind of a pain. So let's factor that up. So you should always write the word limit. I know it's annoying, but do. And x to the 3rd minus 8. So that's a difference of perfect cubes. So one little part, one big part. So I get x and 2. And remember, I do square, multiply, square. So x squared, x times 2 in the middle. So multiply, so I get 2x, and then square the 2, so 4. And then I have to do my signs. Same, opposite, always positive. All right, so this guy right here is going to break up into x squared plus 4 and x squared minus 4. Well, x squared plus 4 is done, but x squared minus 4 can break up into x plus 2 and x minus 2. And so right there, that was key, because I see that x minus 2's go away. And that what was causing me to get the 0 over 0. So now that I have only this numerator and denominator left, now everything's great. I can go ahead and plug in 2 here and 2 there, and it's going to be a nice positive number. Plug in 2 here and 2 here, it's going to be a nice positive number. I'm just going to evaluate this because that got rid of my problem. So if I plug in 2 to the top, I get 4 plus 4 plus 4, so that's 12. Plug in 2 to the bottom, I get, let's see, 4 plus 4, that's 8. And 2 plus 2 is 4. 8 times 4 is 32. So 12 over 32, let me see, divides by 4, so it gets me 3/8. Okay, so there you go. Factoring is always a possibility. And remember, if you can't factor, or if somebody asks you for a table, you always have Desmos to do, like I showed you the last video. All right, so I also want to do a couple more of these, another 2 types of problems, and we'll be done. So my next example is going to have something new in it that you haven't seen before. So limit as x goes to infinity. So you haven't seen that before, but that's fine. That just means when you go far to the right, what happens to your graph. So 3x plus 2 and x minus 4 is my equation. All right, so think of the graph of this thing. This is like your general rational function. It has an asymptote at 4, a vertical asymptote at x equals 4. It has a horizontal asymptote of y equals 3. Remember, that's from this piece right here, and the 4 is coming from this part right there. So the rest of the graph, if you graph it on your calculator or Desmos or wherever, the rest of the graph looks like this. Let's see, it would be up here, and the other part of the graph is down there. Okay, so this is asking me what happens as x goes to infinity. So it's asking me what happens when I go really far that way. So you can see my graph is coming and leveling off and staying at 3. So that's my answer. Now there are more precise ways that you're supposed to do this that you'll learn next year in calculus, but for now we're just going to look at the pictures, and the ways that you're going to learn how to do this are really the rules for why you have horizontal asymptotes. You just never learned it. That's why the horizontal asymptotes were from limits, because you didn't know how to do limits, but now you will. All right, or later you will. So our last example is this. Let's look at this, the limit as x goes to negative infinity. Now, when somebody asks you a limit with infinity in it, you can't really plug that in, and so that's why it's also good to look at the graph. And we're going to do this one, ln of 2 minus x. So this graph right here, y equals ln of 2 minus x. Remember, a log function looks like this. This thing has been moved to and also reflected. When you have a negative right there, that means you're reflecting it over the y-axis. So what happens here, 2 is still my asymptote because x can't be 2 here. So x equals 2 is my asymptote because you can't do log of 0. And it's getting flipped over the y-axis, so it's getting flipped left and right. So the graph actually kind of goes like this. And you can graph on your calculator or Desmos, but this question is asking what happens as x goes this way. So the graph is going up, 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 and it is getting higher and higher and higher and higher. So you are going to answer the graph is going to infinity as you go to the left. And that is it.